Here we want to determine first whether this differential equation is exact. To do that, let's go ahead and move, write it in standard form, which means that we will move determine the right-hand side over to the left, and we'll go ahead and distribute the minus sign that appears, and so we would have ln of x minus 1 dy equals 0. So this would be my m, this is the n in the notes, and so the partial of m with respect to y, now x would be treated as a constant here, and so I get 1 over x from this term. And the partial of n with respect to x gives me 1 over x as well. So this is an exact equation. To solve it, we'll go ahead and realize that f of xy is the integral of 1 plus d ln of x plus y over x dx. I could have chosen the integral of ln of x minus 1 dy. Either one would work, but we'll choose this one. And I'm going to integrate thinking of y as a constant and just using x. And so this gives me x plus the integral of the ln of x dx, which we'll do in a moment, and then plus y times the integral of 1 over x, which is the ln of x. Okay, plus a constant. Now that constant could have some y's in it, so I'll go ahead and write h of y as my constant. Now, just to remind you, the integral of the ln of x is not just 1 over x, but if I do use substitution where I let u be the ln of x and dv is 1, then we want to use integration by parts, and du becomes 1 over x in this case, dx. And here I mean 1 dx. So that v then is x. So if I use this and integration by parts, I get that this integral here, and I'm just going to do the final step, is x ln of x minus x. Okay, so we'll use that and write it here, x plus x ln of x minus x plus y ln of x plus h of y. Notice this x cancels that x, and I have then x ln of x plus y ln of x plus h of y. Okay, so that's f, but if I use this f that I just found right here, then I find its partial derivative with respect to y. Well, this term has no y's, this one does, and gives me the ln of x plus h prime of y. But we know that this should be equal to n, right, which is n of xy, which is this function up here. So the ln of x plus h prime of y needs to be equal to the ln of x minus 1. Well, that tells me that h prime of y should be negative 1, so that h of y is the integral of negative 1, which is, this would be dy, which is minus y. So finally we can get we have h of y, and we have our f of xy, which is x ln of x plus y ln of x minus y. And we know that that function must be equal to a constant. Why is that? Because if you look here, we see that its differential is equal to 0. And this is our answer right here.